Okay, so we're going to deal with absolute value functions. We're going to start with just how to graph them, how to understand them. So the first thing that we're going to do is we're going to compare linear functions and their absolute value functions. So we're going to start by graphing these. Okay, I just took a second there to get everything all graphed up and really nice. So we have here on the left that we have our standard f of x is equal to x. It is a nice straight line through the origin and along a 45-degree angle. And then we have this nice little V shape over here, because we can see that here, 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 and here, everything is normal. But then once we start taking the absolute values of these, we can see that it changes. That these guys here and here look very similar until we get past this point here, which means that we're almost doing a reflection. So what characteristics are similar and different? So they're both straight lines. But the left one can never have negative y values. Why is the absolute relation a function? Well, if we remember correctly, it passes horizontal line test. Are there restrictions on the f of x or the range of f of x? No. But if we look at the range of g of x, y must be greater than or equal to 0, where y is an element of the real numbers. And we can see that because if we scroll up here, that this guy will never, ever go below 0. Okay, let's try that with quadratic functions. So again, I'm going to pause it just to get my graph looking nice, and yeah. Okay, so now that these are nicely graphed, we can see that we have a regular parabola on the left-hand side here. This is the U shape that we are familiar with. And again, once we started getting into those negative y values, we saw a major shift in these three right here. That this little, like the little bottom half of the U got flipped up, and now we have a W. So we can see here that our parabola will have a U or a W right when these guys reflect. So like if I superimposed this guy over, actually that's a good idea. Let's see if I can do that. Okay, I changed this guy's color. Now we're going to move him over, and assuming that my graph was reasonably well done and matched up, we can see here that once this is over top of it, that this guy is almost a direct reflection of this. That this point reflects here, these points reflect here, but these arms are relatively about the same, and that, you can see I got a little sad face over here, that it should line up pretty closely with reasonable expectation for error when it comes to flip-flopping things. So we already talked about which characteristics are similar, for what values of f of x and h of x are the same and are different. So if we look at this, the ones that are the same are 3, 2, -3, -2, and they're different for -1, 0, and 1. Are there restrictions on the domain of f of x and range? Yeah. The range is such that y must be greater than or equal to -3 YER. And restrictions on the range of h of x, yes again, but this time it changes that it must be greater than or equal to 0. So basically, any flies, as long as that value does not dip below, whoops, here. Okay,